Bill Neidlinger at the Town of Newfane Historic Society at our country village. We're in the Loom building where you're looking at a Crompton Knowles 180 D type loom that was made in about 1920 in Worcester, Mass. Was moved here after its work was done at our Lockport Felt Company in Newfane. It was moved in 1985 and then sat for almost 30 years until 2013. At that time, we were able to get three-phase power into the building via a frequency inverter. And at that time then, we started a committee, a crew that comprised of Sam Clogston, Pat Freilich, Gene Weaver, Bob Vigrass, and myself to get the loom operational for our historical purposes.
This is the warp beam that carries the warp threads through these heddles that are on frames that are called harnesses that carry the threads through this reed onto the cloth and down to the cloth beam, which is sometimes called an apron. This is the shuttle that carries the filling yarn or the woof yarn to fill the warp yarn to make the cloth.
We have here a 180-inch Crompton Knowles D loom, which is powered by a three-phase motor through gearing, which drives a crankshaft driving a lay, which beats the filling yarns into the intersection of the warp yarns and forms the fabric.
Okay.
In the action of weaving, the picker stick, this device here, thrusts the shuttle across the face of the loom, carrying the filling threads through what is called the shed, which is formed by the intersection of the various and sundry warp beams, warp threads supplied by the warp beam. That way we get a woven fabric as a result. this 180-inch D loom by Crompton Knowles has on this end, as shown in the picture, what is known as a Crompton Knowles, a Crompton head motion. This is a mechanical device which controls all of the mechanical actions on this loom, which include the action of the picker on the shuttles, the take-up motion, the raising and lowering of the harnesses, and the action of the pattern chain, which is the controlling factor on whether you're weaving plain, AWA, SAV, or any other type of weave which can be executed on 8 harnesses. One device that is an interesting feature of this Knowles head motion is the pattern chain, which we have here. And it consists of rollers which are called risers and non-rollers which are called sinkers. The risers call the harnesses to rise, cause the harnesses to rise, while the sinkers cause the harnesses to lower. And the way these are arranged will arrange the type of weave which the loom is going to produce. We can make a plain weave, which is the way the loom is set up at the moment, or we can make a 3-in-1, or what is called an SAV, which is a 2-sided 3-in-1, or an SAV. There are many combinations of arrangements of the risers and sinkers to take care of the various and sundry weaves that are almost innumerable. The action is performed by the 2 cylinders which we have here, which raise and lower the harnesses through the action of gap gears on the vibrators, which are shown in this close-up. And we will turn it by hand to show the action of the vibrators and the gap gears. 180-inch D-loom is capable of weaving fabrics basically for the wet felt blankets which are used on paper machines. The product off the loom, which is similar to what we have here, is typical of a base fabric for these applications. This happens to be a 3-in-1 weave, while the one in the loom is set up to weave plain. From the loom, this fabric goes to the finishing room, which is where it is felted, napped, and processed before shipping to the customer. An innovation of the woven and mechanically and fold of felted fabric was the fabric produced by a fiber locker, where we take a base fabric and apply a fibrous bat to the surface, and this bat is needled into the base fabric with felting needles, of which we have some on display. This is the typical surface. It's a terrible example of it. It's dirty. But this is the surface is produced on the fiber locking machine. World War II created a need for blanket material for the armed forces, and the felt company was destined to weave a plethora of blankets for both all armed soft surfaces. An example of which we have in here, complete with moth holes. This being 100% wool fabric, the moths just loved it. To the paper business, the felt company also produced a material called sand screen base fabric, which was, as shown, a screen type fabric which was sent to abrasive companies where they added abrasives to it and made what is called sand screen, a product used by the automotive industry primarily.
Where we have some nice looking weaving. Shuttle, a cap, then it goes through the plates in here so that the new thread can be brought through. The strap comes down over the shuttle to hold the cap in. Shuttle is put into the shuttle box.
You have to stand on that.